Hello everyone, I am Srivanti and I am currently working as an ML engineer. I have covered basic concepts and maths behind regression in this video, link in description, and I would strongly recommend seeing that video before starting to solve the interview problems. Okay, so the next question that comes is, what is the bias-variance trade-off? So this is a very important question that is often asked in interviews. Bias, what do I mean by bias? First, I'll explain the terms. So bias actually means the error which is actually introduced when we are trying to find out or predict a particular problem or a particular data. So y equal mx plus c, this is the line that we are trying to find, right? Best fit line. So this bias is actually this error, the residual, the difference when we are finding out the model. So high bias, what does it mean? So high bias means that when the model is very simple and it's unable to capture all the patterns and all the features of the data properly. So that is when it leads to underfitting. So what do I mean by that? So for example, suppose I have a model which looks like a curve. So suppose the model is a circle. The data is actually a circle. And we are trying to use linear regression to fit it. Right. So a line cannot obviously capture all the features of a 2D curve. That is why here the model is said to have high bias. Next comes variance. So variance is the model's sensitivity to very small things in the data. So for example, like suppose we have very less data, then the model overfits on that data. So then what happens is that the model learns not just the patterns in the data, but also the noise, which is not good because obviously a model will definitely have noise. There's the epsilon that I said earlier, which is the residual. Suppose the model is actually a curve, which is a straight line, right? So this is the model and this is the data basically, and we're trying to fit it using a 2D curve. So what would happen in that case is that the model will learn all the noise in the data, and that is why it's also again useless. So that is why what we need here is a bias variance trade-off, which is very important. So now the question comes is that how can we actually manage this bias variance trade-off? So one thing is definitely getting the dataset into a pandas data frame. So this will help us in analyzing the dataset better. So pd.read CSV. So my dataset is basically inside a data folder. You can also do that. .csv. Yeah. So you can just download the dataset from the Kaggle and then you can simply get the dataset out. So, store it in a particular folder where you'll be doing all your projects and all. So the next thing is that what is X? X would be DS. I think the name was years experience. Years experience. Dot values. And Y would be salary. Dot values. Great. So if you want to see what does X look like and what does Y look like. Great. So we have X and Y currently. So now the next step is to plot these points. So this is a very important step, whether to know which algorithm to use. So if I am plotting this point, if you see here, you would be able to see that like this is almost like a straight line. You can almost trace the straight line here through these points. So this is what the dataset looks like, and we can see that the best fit line will be a straight line. This does follow a straight line. It's not a circle, it's not any other kind of oval or anything, it's a straight line. So one thing is definitely regularization to find the best balance of the data. So what do I mean by that? I'll discuss regularization soon. But what does it mean? What it means is actually when you're trying to find out y equal mx plus c, then you want to add a penalty for the complexity so that the model doesn't overfit. So regularization, I'll discuss again in the further question. And okay, so what do we generally do when it comes to validation? So we actually divide our data into training data and validation data, and then we try to use the validation data to find out whether our model, to find out the exact point at which our model should stop training. Because as you know, so this is the train curve which goes down, the loss curve, and this is the validation loss curve. And we find out the point to where we stop our training, and we think that convergence has happened, is when the validation loss and the training loss both are at the minimum. So both should be at the minimum at that point. So I hope this helps. Please drop your questions in the comments if you want me to cover any other function. If you did not understand anything, I would strongly suggest to rewind it and to try to understand it. But if you still don't get it, you can drop a comment below and I'll try to answer it. I hope this helps. Thank you.